In this video, we're going to look at another example of areas between curves. And the question here is to find the area of the region bounded by the curves y equals log x over x, y equals 1 over x, and the lines x equals 1, x equals 4. The first step, as usual, is to find the intersection points of the functions y equals log x over x and y equals 1 over x. So let's do that. We'll let y equals y, and that means log x divided by x is equal to 1 over x. Let's cross multiply, and we're going to get x log x is equal to x. Let's bring everything to the left hand side. We get x log x minus x is equal to 0. Let's factor out x. We get x times log x minus 1 is equal to 0. We get two solutions. X equals 0, which we're going to reject, and we'll talk about that. And we'll also get log x minus 1 equals 0. Add 1 to both sides, we get log x is equal to 1. Exponentiate both sides, we get e to the log x is equal to e to the 1. But e to the log x is just x, so we get x equals e. We can substitute this into either equation to recover the y value. I'll put into y equals 1 over x. That gives us y is equal to 1 over e. That means x equals e, y equals 1 over e is the intersection point on the interval between 1 and 4. On the interval x between 4 and 1, this is the intersection point of the two functions. Now, back to the fact that we're going to reject x equals 0. Why do we do that? Reject x equals 0. It's because it's outside the domain of y equals log x over x. For two reasons. One is you can't have 0 in the denominator. You can't have x equals 0 in the denominator. And the second reason is the domain of the numerator does not permit it. Log x is only defined for x larger than 0. So this is our only intersection point. All right, the next step is to sketch a region, sketch the bounded region, y equals log x over x and y equals 1 over x. And we've done that here. Notice that when x is between e and 1, 1 over x is larger than log x divided by x. So the top point of the rectangle is going to be 1 over x. The bottom point of the rectangle is log x over x. So the difference of the two forms the height. The differential area is going to be the top y value, which is 1 over x, the larger y value, minus the smaller y value, which is log x divided by x, times dx. Let's draw a typical rectangular slice. So here we have the height of this rectangular slice is 1 over x minus log x divided by x. The width is dx, and this is the differential area described by this quantity 1 over x minus log x over x times dx. All right, you will also notice that when x is between 4 and e, that means to the right of the intersection point from e to 4. So we can tell that log x over x now is a top function. So log x over x is larger than 1 over x. So the differential element dA will be log x divided by x minus 1 over x dx. Let's also illustrate this with a rectangular slice. So now the top function is changing. So the top function is log x over x. The bottom function is 1 over x. This is y top minus y bottom. And the width is dx. And when you multiply the width times the height, you get a differential area right here. All right, we're now set up to do the definite integral, so now it will be easy. Let's review what we have found so far. We found that the intersection point of y equals log x divided by x and y equals 1 over x, that intersection point was found to be x equals e, y equals 1 over e on the interval x from 1 to 4. So we also noticed that 1 over x is larger than log x divided by x when x is between e and 1, and also log x over x is larger than 1 over x when x is larger than e and less than 4. And we saw that from the diagram here. You can clearly see that 1 over x is larger than log x over x when x is between 1 and e. And to the right of the intersection point, log x over x is the top function and 1 over x is the bottom function. So we have to describe the two regions separately. And we have to set up two separate definite integrals to describe the area of the region. All right, so the definite integral is going to be area is equal to integral from 1 to e, 1 over x, minus log x divided by x, dx, plus integral from e to 4, log x over x, minus 1 over x, dx. Now let's first find the integral of log x over x. We're going to need it. How do we integrate this? This is an easy integral. We're going to apply the U substitution method. We let u be equal to log x because its derivative gives us 1 over x dx. Differentiate both sides, we get du is 1 over x dx. So we get integral, log x is u, dx over x, all of that is just basically du. Integrate u with respect to u, and we get u squared divided by 2 plus c. Now put u back in, and we get log x all squared divided by 2 plus c. Alright, so the area is integral from 1 to e, 1 over x minus log x over x dx, plus integral from e to 4, log x over x minus 1 over x dx. We just have to integrate it now. So area is going to be equal to, what is the antiderivative of 1 over x? That's just log x. And we already found the integral of log x over x using U substitution method. That's log x squared divided by 2, evaluated from 1 to e, plus integral log x over x, we already found that, that's log x squared, divided by 2, minus integral 1 over x is log x, from e to 4. Alright, let's put the top limit and bottom limit in. Let's apply fundamental theorem of calculus. Putting the upper limit in, we get log e, minus log e all squared, divided by 2, minus log 1, minus log 1 squared, divided by 2. And let's put brackets around this. And then plus, now we'll take care of this part. Putting the upper limit in, we get log e, all squared divided by 2. Sorry, we're putting the upper limit in, so that's going to be plus log of 4. That's the upper limit, divided by 2, minus log 4, minus, now put a lower limit in, and we get log e, all squared divided by 2, minus log e, and we close the bracket here, and another close here. Alright, so now we have to evaluate this. What is log of e? Log of e is 1. Log e is 1. What is log of 1? That's 0. Log of 1 is 0 again. Log e is 1 again, and log e is 1. Very easy to make mistakes, so we got to be really careful with this. So log e, that's 1. 1 minus 1/2 minus 0 minus 0 over 2, which is just 0, plus, and then we have log 4, all squared over 2, minus log 4, minus, and then we have 1/2 minus 1, which is negative 1/2. So if we simplify this, we get the area is equal to 1 minus 1/2, that's 1/2, plus log 4, all squared divided by 2. And then we have minus log 4, minus log 4. And then we also have plus 1/2 here. That's from here. Minus times minus gives us plus. So if we simplify this, what do we get? We get 1/2 plus 1/2, that's 1, plus log 4, all squared divided by 2, and then we get minus log 4. if you decimalize this, put this into a calculator, it comes out to approximately 0.57. That represents the green shaded area that we have on this page right here. That's the shaded area using integration, setting up the two different regions and integrating it. Not too hard. All right, let's now review some properties of logs. So integral 1 over x dx is equal to log of absolute value of x plus c. But you might have noticed we didn't use the absolute value, and the reason is the domain of log x is x larger than 0, and we were integrating from 1 to 4. Let me double check that. Yes, we're integrating from 1 to 4, and definitely in this interval, x is positive, so we don't need the absolute value. Basically, absolute value of x is x when x is positive. So when we did the integration from 1 to e, 1 over x dx, this is just log x, log absolute value of x from 1 to e, but we don't need the absolute value because the interval is from 1 to e in this case. So we get log of x from 1 to e. Put the upper limit in, that's log e minus log 1. We're just showing one of the integrations. Log of e is 1, log of 1 is 0. 1 minus 0 is equal to 1. All right, so a couple of things that you really have to memorize. Log of 1 is 0. Log of e is 1. E to the ln x is equal to x. Log of e to the x is equal to x. Also, make sure you can graph the log function. Log x has a graph like this. It has an x-intercept of 1. It has a vertical asymptote, y-axis. As x approaches 0 from the positive side, the y value goes down to minus infinity. And as x goes to infinity, the y value goes to infinity. This is the graph of y equals log x. Just a bit of review for the basic skills. All right, thank you.